Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the about the problems on diagonalization of a matrix. Once again, today I want to discuss about the problems on diagonalization of a matrix for distinct eigenvalues. Already we discussed in the last class what is diagonalization of a matrix theory part. Once again, I'll repeat that theory, how we are finding the diagonalization of a matrix problem through the concept. Okay. What about the concept of the diagonalization of a matrix? First of all, we have to verify the given matrix is square matrix. Okay, I have to verify the given matrix as square matrix. After that, for the square matrix, we have to find eigenvalues. And after that, we have to find eigenvectors. These are lambda 1, lambda 2, and so on up to lambda n. And eigenvectors x1, x2, and so on up to xn. After that, write it as this as one model matrix form. This P is called as model matrix. This P is called as model matrix. For that P, we have to find inverse. That is P inverse is equal to adjoint P by det P. Okay, for finding P inverse is equal to adjoint P by det P. After getting that P inverse, here we have to find D is equal to multiply P inverse with A into P. P inverse A into B. This is D. Okay. This D is called diagonal matrix. This D is called diagonal matrix or spectral matrix. Okay. This is the formula for the diagonalization of a matrix. Okay. This is the concept for finding the given matrix reduced as diagonal form. Okay, here we have two cases. What about the first case? Okay, here if once observe before going through discuss the cases, here D is equal to P inverse of AP. This D means what? Diagonal matrix. That diagonal elements are equal to what? The given. Okay, what you are getting the eigenvalues, the diagonal elements are equal to the eigenvalues. There only our answer is right. Okay, for finding diagonalization of a matrix, here two cases are there. What about the first case? Okay, if the eigenvalues are distinct. Okay, if the eigenvalues are distinct, definitely that matrix is diagonalizable. Okay. If the eigenvalues are similar, for that case, first of all, we have to verify algebraic multiplicity and geometric multiplicity. If the two are equal, then the given matrix is diagonalizable. Okay, for directly, if the given matrix is getting the eigenvalues are distinct, means definitely that is diagonalizable. First of all, I want to discuss about that the eigenvalues are distinct for the given matrix. Okay. First question, find a matrix P which transform the matrix A is equal to 1 0 minus 1 1 2 1 2 2 3 to a diagonal form. Hence calculate A power 4. Okay. Once observe the given matrix is square matrix or rectangular matrix. This is 3 by 3 matrix. So that this is square matrix. For that square matrix, what is the first step for finding the diagonalization of a matrix? For the given matrix, first of all, we have to find out the eigenvalues. How you are finding the eigenvalues? What about the formula for finding eigenvalues? By using the characteristic equation only, we get the eigenvalues. For that, I am taking the characteristic equation of A is given by det A minus lambda I is equal to 0. Characteristic equation of A is given by det A minus lambda I is equal to 0. Here what is A? Given matrix. A is given matrix. And according to that, what about I matrix? I as unit matrix or identity matrix. Here the given matrix is 3 by 3, so that you have to take the identity matrix also 3 by 3. Matrix is 3 by 3. Okay. For that, I am taking the characteristic equation form. Determinant of A minus lambda I is equal to 0. For that, here, what about the given matrix? 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Minus lambda into, what about I? Identity of 3 by 3 matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to 0. Okay. For that, we have to subtract. Here lambda is what? That only we have to find out the eigenvalue for the lambda. That is unknown value. Okay. Now we have to subtract these two. How we are subtracting? First of all, we have to multiply with the lambda. That is 1 minus lambda into 1. That is 1 minus lambda. And 0 minus lambda into 0. 0. Next minus 1 minus lambda into 0. Minus 1. Next one 1 minus 0 into lambda 1. And 2 minus lambda. And next 1 minus lambda of 0. That is 1. And next this is 2. Next 2 and 3 minus lambda is equal to 0. That is 1 minus lambda 0 minus 1, 1, 2 minus lambda 1, 2 lambda is equal to 0. From that characteristic equation, we get one characteristic matrix. Okay, for that we have to find determinant value. How we are finding the determinant value for that? Okay, according to the first element here, whatever the first element 1 minus lambda, neglecting the corresponding row and column. For that we get 1 minus lambda into whatever the remaining part after neglecting that corresponding row and column, 2 minus lambda into 3 minus lambda minus 2 minus 0 minus 1 into neglecting the corresponding row and column, and 1 into 3 minus 2 minus 2 into 2 minus lambda is equal to 0. Okay, after simplifying that, we get directly what about the equation form here? Lambda minus 1 into lambda minus 2 into lambda minus 3 is equal to 0. For that, equating each and every term with 0. For that, whatever the lambda values, lambda is equal to 1, lambda is equal to 2, and lambda is equal to 3. Therefore, here we get 3 eigenvalues for the 3 by 3 matrix. What are the 3? Lambda is equal to 1, 2, 3. Once observe, these 3 are distinct eigenvalues or similar eigenvalues, distinct eigenvalues. Distinct eigenvalues. What we discussed previously, if the eigenvalues are distinct means, for that case the given matrix is definitely diagonalizable. Okay, if you, this we know. Okay, in this step only we know if the eigenvalues are distinct means definitely that matrix is diagonalizable. So that we have to continue the next concept of the diagonalization of a matrix. For that, after getting that eigenvalues are distinct, we have to find each and every eigenvalue that corresponding eigenvectors. Eigenvectors. What about the concept for finding eigenvector? This is the formula. Okay, if x1, x2, x3 be the components of an eigenvector corresponding to the eigenvalue of lambda, that means what? If you are finding lambda is equal to one eigenvector that correspond, if we are finding lambda is equal to one eigenvector, we have to assume that eigenvector as x1. Similarly, if lambda is equal to 2, for that corresponding eigenvector, we have to assume that as x2. And that similarly, if lambda is equal to 3, that corresponding eigenvector, we have to assume that as x3. Okay, now for that, we have to find that x1, x2, x3 through the concept. For that here, what about the formula for finding eigenvector for each eigenvalue? That is a minus lambda I into x is equal to 0. That formula is a minus lambda I into x is equal to 0. This is here already we know that a minus lambda I is the characteristic matrix form. That is 1 minus lambda 0 minus 1 1 2 minus lambda 1 2, 2, 3 minus lambda x1, x2, x3 is equal to, here what about x? I'm assuming as small x1, small x2, small x3 are the unknown values of the matrix, that is capital X form, one column matrix, that is. Okay, this is the common. Okay, this a minus lambda I into x is common for all for finding the eigenvectors. For that here I'm taking lambda. What about the first value here? Lambda is equal to 1. For lambda is equal to 1, now I am to find out the corresponding eigenvector. For that, this is a minus lambda I into x is equal to 0 form. For that, first of all, I am substituting lambda is equal to 1. Okay, if you are substituting lambda is equal to 1, how it will change? That is 1 observe there. That is 1 minus lambda is 1. This is 0. This is minus 1, 1, 2 minus 1, 1, 2, 2, 3 minus 1 into x1, x2, x3 is equal to 0, 0, 0. Once observe after subtracting with the lambda is equal to 1, 1 minus 1 as 0. And the next one 0. And next one minus 1. And the next one 1. 2 minus 1, 1, 1. Next one 2, 2, 3 minus 1 as 2 into x1, x2, x3 is equal to 0, 0, 0 form. Okay, now here once observe, here after substituting lambda is equal to 1, we get one matrix form, that is 0, 0, minus 1, 1, 1, 1, 2, 2, 2, x1, x2, x3 is equal to 0, 0, 0. For that, here from that we have to find out unknown values of x1, x2, x3. For that, now we have to reduce the matrix as echelon form. Okay, if you are reducing the matrix as echelon form, easily we can get the unknown values of x1, x2, x3, or else we have to use, okay, directly write down the equation forms and solve that equations. We get unknown values of x1, x2, x3. Which one is easy, then you can follow that method for finding unknown values of x1, x2, x3. Here I am using the echelon form for finding the unknown values of x1, x2, x3. For that, what about the concept of the echelon form? Echelon form means what? Here once observe, this is the given matrix. For that given matrix, we have to reduce below the diagonal values are the, okay, zeros with respect to the row operations. Okay, with respect to the row operations. For that I am using, for that this is the matrix. For that I am using the echelon form for reducing as a matrix. Okay, then here once observe, before applying that echelon form, first of all I'll interchange the rows. Here I'll interchange R2 interchange to R1. That is 1, 1, 1, 0, 0, minus 1, 2, 2, 2 into x1, x2, x3 is equal to 0, 0, 0. Okay. Now, what about the R1 row 1 1 1 and R2 as 0 0 minus 1 and R3 as 2 2 2. Okay. Now I am applying the row operations by making as R2 first element and R3 first element as 0. But unexpectedly here what will happen? There are two first element as 0. That's why no need to apply the row operation for on R2. Okay. Directly I am applying with respect to R1. I'll make it as R3 first element as 0. For that, what about the row operation? Tell me. R3 tends to R3 minus 2R1. R3 tends to R3 minus 2R1. For that, 1, 1, 1. There is no changes in the second row. That is 0, 0, minus 1. And next 2 minus 2, 0. In the next one, 2. Here 2 minus 2 into 1. 2 minus 2, 0. And similarly 2 minus 2, 0. Into x1, x2, x3 is equal to 0, 0, 0. Okay. Once after using R3 in a row with respect to R1, then directly R3 completely as zeros. That means once observe, is it echelon form or not? This is echelon form. Okay. After finding as echelon, reducing as the matrix as echelon form, now we have to write it as equation form. Once observe, here if all are zeros means, now write it as the equation. Easily we can get the values of the x1, x2, x3. Now I'll write it as the equation. Here, whatever the first row 1, 1, 1 with multiplying with the first column. That is 1 into x1 plus 1 into x2 plus 1 into x3 is equal to 0. Similarly, what about the next one? 0 into x1 plus 0 into x2 minus 1 into x3 as 0. From this, there is no third equation. Directly all are zeros. Okay, from the second equation, once observe, here x1 0, x2 as 0. From that we get directly x3 is equal to 0. What about x3? x3 as 0. And what about the first equation? This is the first equation. From the second equation, we get one unknown value of x3 that as 0. Now we have to find x1 unknown values of x1 and x2 from the one equation. How we are finding that x1 and x2 from one equation? Okay, for that I'm assuming let x2 as k. I'm assuming x2 as k. Substitute in the first equation. Okay, from that x1 plus k, and what about x3? 0 is equal to 0. I'm substituting in the first equation. 1 into x1. I'm assuming x2 as one arbitrary constant, that as k, and x3 value directly from the second equation. How much we get? 0. That is 0. That means from that x1 is equal to how much? Minus k. Therefore, what about x1? Minus k. And what about x2? K and x3 as 0. Okay. Once observe, there we get x3 as 0, and here this is different, or else this is also correct. From the first equation equating with the substitute x3 as 0, from that x1 is equal to minus x2. From that also we get x1 as 1 and x2 as minus 1 and x3 as 0. This is one concept, or else if you are confusing with that, from that we have to assume x2 as k. Okay, assuming x2 as k, from that we get x1 value. So that here, what about x1? x1 as x1 is equal to minus k, and x2 is equal to what? x2 is equal to k, and x3 is equal to 0. Write it as one vector form. This is, that is eigenvector x1 is equal to x1, x2, x3. That means what? Minus k, k is 0. From that I am taking k outside, or else minus k outside. That is 1 minus 1 0. 1 minus 1 0. Once observe that eigenvector is what? 1 minus 1 0. We are assuming as k as one variable as arbitrary constant. From that also we get the same answer. Or else if the possibility is there from the first equation, if directly x3 as 0, then equate x1 is equal to minus x2. There also x1 is equal to 1 and x2 is equal to minus 1 and x3 as 0. From that also we get the same answer. Or else if you are taking any value as arbitrary constant, from that also we get the same answer. That means here what? If lambda is equal to 1, that means the corresponding eigenvector is what? 1 minus 1 is 0. Similarly, we have to find lambda is equal to 2 eigenvector and lambda is equal to 3 eigenvector with the same concept. Okay, from that now I'm finding lambda 2 corresponding eigenvector. That is, if lambda is equal to 2, that corresponding eigenvector, what about the formula? A minus lambda I into x is equal to 0. From that, what about a minus lambda I into x? That is 1 minus lambda, 0 minus 1, 0 minus 1, and next 1, 2 minus lambda 1, 1, 2 minus lambda 1, and the 2, 2, 3 minus lambda, 2, 2, 3 minus lambda into unknown values x1, x2, x3 is equal to 0, 0, 0. Okay, once observe there, is it right or not? 1 minus lambda, 0 minus 1, 1, 2 minus lambda, 1, 2, 2, 3 minus lambda into unknown column vector capital X as I'm assuming as x1, x2, x3. Okay, from that here, what about the lambda value? I'm substituting there. That is 1 minus 2, 0, minus 1, 1, 2 minus 0, 1, 2, 2, 3 minus 0 into x1, x2, x3 is equal to 0, 0, 0 form. Okay, from that 1 minus 2 means minus 1, 0, minus 1. And next 1, 2, 1. Next 1, 2, 2, 3 into x1, x2, x3 is equal to what? 0, 0, 0. Okay, this is the vector form. Again, after getting this matrix form, now write this as matrix as echelon form for solving unknown values of x1, x2, x3. For that here, once observe, here minus 1, 0, minus 1, 1, 2, 1, 2, 2, 1. What about the concept of the echelon form? Below the diagonals, we have to reduce as 0 with respect to the row operation. From that, I am taking here, what about the below the diagonal elements? 1, 2, 2. With respect to row operations, I'll make it as zeros. That's concept as, first I'll make it as R2 with respect to R1 and R3 with respect to R1 only. R3 first element. From that, what about the row operation? R2 tends to R2 plus R1. Why? Because here 1 and this is minus 1. 1 minus 1, 0. Similarly, R3. What about R3? R3 plus 2R1. R3 plus 2R1. For that, this is minus 1, 0, minus 1. And next 1 with respect to R1, I'll make it as R2 as 0. That is 1 minus 1, 0. Next to 2 minus 0, 2. And 1 minus 1 as 0. Similarly, what about R3? 2 plus minus 2 into 1. 2 minus 2, 0. Next 2 plus 0 into 0, that is 2. Next 3 minus 2, that is 1 into x1, x2, x3 is equal to 0, 0, 0. Once observe, is it right or wrong? R3 row with respect to R1, 2 minus 2, 0 and 2 minus 0, 2 and 3 minus 1 into 2, 3 minus 2, 1. Okay, this is the row operation. Is there any possibility to make this as 0? It is possibility is there with respect to R2 second element. Then what about the row operation for that? Tell me. That row operation is here. I'll write it here. That is R2 tends to R2 minus R3. that is minus 1, 0, minus 1, 0, 2, 0, 0, 2 minus 2, 0, and next R2 minus R3. That is, okay, sorry, this is R3. I'll make it as R3. I'm changing R3 value with respect to R2, right? That means 0 minus 0, 0, 2 minus 2, 0, and next 1 minus 0, 1 into x1, x2, x3 is equal to what? 0, 0, 0. Once observe here, any possibility is there for making as 1 as 0? No. This is echelon form. Below the diagonals all are zeros. Now write it as equation form. Okay, first of all. Okay, from that write it as equation form. That is minus x1 plus 0 into x2 minus 1 into x3 is equal to 0. Similarly, here 2 into x2 is equal to 0. And what about the next one? X3 is equal to 0. X3 is equal to 0. From that, once observe there, here directly, here minus 1, 0, minus 1 is equal to 0. 2x2, and is there any possibility to make this as, and x2, x3 0, and x1 as 0. Okay, once observe minus 1, 0, minus 1. No possibility to make this as 0. Okay. And next one is K. Okay. Here we have to observe minus x1 plus 0 into x2 minus 1 into x3 as 0, and the another equation 2x2 is equal to 0, and the next one x3 as 0. From that here we get x2 value as 0 and x3 0, and what about x1? We are substituting the 2, then directly x1 as also a 0. Okay, but it is not right. Maybe wrong here. Minus x1 plus 0 into x2 minus 1 into x3 is equal to 0. 2x2 is 3 minus r2, 2x2 is 0, and x3 is equal to 0. And assuming x1 as k. Okay. Okay, through the concept here, some mistake is there, but through the concept we get if lambda is equal to 2, for that case we get the value of minus 2, 1 and 2. If lambda is equal to 2, for that case we get the eigenvector, as x2 is equal to, okay, this is the right concept, but here we get x2 is equal to, according to this, here x2 as x1, x2, x3. From that we get minus 2, 1 and 2. Okay, this is the second eigenvector. Okay, next similarly, if lambda is equal to 3. If lambda is equal to 3, for that case here, okay, we get the eigenvector as minus 1, 1 and 2. Okay, minus 1, 1 and 2. Once observe for the distinct eigenvalues, here we get 3 eigenvectors. First one as lambda is equal to if x1 is equal to 1 minus 1 0, and x2 as minus 2 1 2, and x3 as minus 1 1 2. These are the 3 eigenvectors. Write it as the 3 as one matrix form, the P, that is column wise write down 1 minus 1 0, minus 2 1 2, minus 1 1 2. Therefore this is P matrix. This P is called what? This P is called as a model matrix of A. Okay. Therefore, for the distinct eigenvalues, we get here 3 distinct eigenvectors. Write it as one matrix form. That matrix is called as a model matrix. For that model matrix here, I'm finding P inverse. What about P inverse? P inverse is equal to, what about the formula of P inverse? Adjoint P by det P. Okay, first of all, I'll find out the det P value. Okay, from the given matrix. What about the matrix? From the model matrix, we get dead p value, that is 1 into 2 minus 1 minus plus 2 into minus 2 minus 0 minus 2 minus 0 plus minus 1 into minus 2 minus 0. There minus 2 minus 0. From that 1 into 2 minus 1 as 1 minus 4 and there plus 2. Okay, minus 4, 1 subs are 2 minus 1 1, 2 2s are 4 minus 4 and 1 into minus 1 into minus 2 plus 2. From that we get directly that p is equal to how much? Minus 4 2 minus 1 into minus 2 minus 0. Okay, from that we get directly there value 1 by 2. Okay, that means 2. 2 minus 2, 4, 2 minus 1, 1. Okay, from that we get directly 2. Therefore, det P is equal to 2. P inverse is equal to adjoint P by det P. From that det P value is equal to 2. Okay, from that we have to find adjoint of P. Okay, adjoint of P formula already we discussed in the last class. According to that we get 0 to minus 1, 2 to 0, minus 2 minus 2 minus 1. Okay, now after getting that P inverse, multiply P inverse with A into P. Okay, from that here we get P inverse matrix and A matrix and P matrix. Multiply 3, okay, through the calces. For the scientific calculators also have to multiply the 3 matrices. Easily we can get the answer, or else we have to apply the manual procedure for multiplying of the matrices. Okay, which one is easy? You cannot follow that method, but by scientific calculators only it is easy to multiplying of the matrices, or else it will take a very long time for finding multiplication of the matrices. Okay, for that here P inverse AP is equal to what? That is we get 1 0 0 0 2 0 0 0 3. This is diagonal matrix. This is diagonal matrix. Once observe this diagonal matrix D, that matrix diagonal elements are is equal to what? Already I discussed in the concept. This diagonal elements are equal to the what? Given after the eigen values. Here eigen values are 1 2 3 and their diagonal elements also 1 2 3. Therefore both are equal, then the given matrix is diagonalizable. Therefore, D as the diagonal matrix. Okay, this is the first case of the question. And after what they are asking in the question, there once observe, hence calculate a power 4. Okay, hence calculate a power 4. Okay, in the theory I discussed. What about the formula for a power n? A power n formula p into d power n into p inverse. And what about a power 4 formula? P into d power 4 into P inverse. A power 4 is equal to what? P into d power 4 into P inverse. What about d power 4? Already we know that P as model matrix and P inverse as the adjoint P by det P matrix, and d power 4 is after getting that D. Okay, then take the powers of 4, that is d power 4. That means what? Here P is equal to 1 minus 2 minus 1 and minus 1 1 1 0 to 2, and d power 4 means what? Here I discussed with d power 4, that is 1 power 4 0 0 0 2 power 4 0 0 0 3 power 4. Okay, then from that we get 1 0 0 0 2 power 4 means how much? 16 0 0 0 3 power 4 means how much? 81. This is equal to d power 4, that is 1 0 0 0 16 0 0 0 81, that is d power 4. This is d power 4 and this is p, and this is p inverse. Multiply these three with the scientific calculators or else manually. We get the final answer minus 49 minus 50, minus 40, 65, 66, 40, 130, 130 and 81. This is the answer for A power 4. Okay, therefore from the first question we learned, okay, from reducing as matrix as diagonal matrix, after getting as D, here we are finding A power 4. Okay, these two cases over from the question. Sometimes they are asking directly find A power 4. Okay, how we are finding A power 4 without the diagonal form? No need to apply A as 4 times. Okay, here through the concept, through the diagonalization form only, we get the A power 4 form. But for multiplying A as 4 times, we get the same answer. After using the diagonalization of the matrix also, A power 4 value is also same. Okay, but through the concept only, we have to find A power 4 from the module 2. Okay, this is the concept for the first question of the diagonalization of that form. What about the form of the diagonal? Here the distinct we discussed with what for the distinct eigenvalues concept. First of all, we have to find eigenvalues and the corresponding eigenvectors and write it as the eigenvectors as one matrix form. That matrix is called as the diagonal matrix from the, model matrix. From that model matrix, we have to find P inverse, and after finding P inverse, okay, and P inverse is multiplied with A and P. From that we get a diagonal matrix. Okay, the diagonal matrix, diagonal elements are always equal to the what? The eigenvalues. If the two are equal, then the concept is right. After that, find A power 4. What about A power 4? P into B power 4 into P inverse. From that we get A power 4 matrix. This is the concept of the diagonalization form for the distinct eigenvalues. Okay, I'll go through the second question. Okay, second question. Okay, once observed. Second question, determine the model matrix P of minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Verify that P inverse A into P is a diagonal form. Okay, here what they are given differently, but whatever it is, this is diagonal form only. Okay, now determine the model matrix. What is model matrix? We know that after finding the eigenvector as a, write it as one matrix form. That matrix is called as a model matrix. Okay, after that we have to verify P inverse AP is diagonal form or not. Okay, then for that, first of all, same concept. What about the characteristic equation of A is here? Characteristic equation. Once observe before writing the characteristic equation, is it a square matrix or rectangular matrix? This is square matrix. This is square matrix. For that square matrix, now write it as characteristic equation. What about the characteristic equation form? Determinant of A minus lambda I is equal to 0. For 3 by 3 square matrix, here what about identity? 1 0 0 0 1 0 0 0 1. Okay, that is the identity matrix. For that, write it as A minus lambda I, that is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Minus lambda into 1, 0, 0, 0, 1, 0, 0, 0, 1. Determinant of is equal to 0. Now subtract these two, that is minus 2, minus lambda, 2, minus 3, 2 minus lambda into 0, 2, 1 minus lambda minus 6. Next one, minus 1, minus 2, 0 minus lambda minus lambda. This is equal to 0. Once observe, from the characteristic equation we get one characteristic matrix form. Okay, and now we have to simplify with the determinant. We get already we discussed in the last classes and the previous problem also. Okay, from that find the determinant of the given matrix. From that, lambda minus 5 into lambda plus 3 whole square is equal to 0. From that, what about lambda value? Lambda is equal to 5 and lambda is equal to minus 3 and lambda is equal to minus 3. Okay, here we get 1 as distinct eigenvalue and the remaining 2 are, once observed, the 2 are similar eigenvalues, right? For the two similar eigenvalues, the given matrix is diagonalizable or not? It is may or may not. There already I discussed that concept also for similar eigenvalues. For that case, what about the concept for the similar eigenvalues? We have to verify algebraic multiplicity and geometric multiplicity. Algebraic multiplicity means what? After getting that eigenvalues, if you get okay, minus 3 repeated how many times? 2 times. Minus 3 algebraic multiplicity is how much? 2. Okay, now similarly after getting this, okay, now we have to find the corresponding eigenvectors. After finding that eigenvector, if the similar eigenvalue, we get the similar, if the, for similar eigenvalues, in that one case only we get two linearly independent eigenvectors. Okay, if you get the two linear eigenvectors, okay, for the geometric multiplicity as 2. Is it clear all of you? Okay, for the similar eigenvalue, you have to find the corresponding eigenvectors. Okay, if you get two eigenvectors, okay, that means if you get two eigenvectors means the geometric multiplicity is how much? 2. Sometimes for the similar eigenvalues, we get only one eigenvector. One eigenvector. For that case, the geometric multiplicity is how much? 1. Okay, if it is 1 means that algebraic multiplicity and geometric multiplicity is are not equal. Therefore, the given matrix is not diagonalizable. Okay, now here we have to observe. Okay, here we have to observe algebraic multiplicity and geometric multiplicity are equal or not. Maybe here the two are equal. Okay, that means here maybe we'll go through that. Maybe their geometric multiplicity is 2. If it is 2 means these two are equal, then the matrix is diagonalizable, so that we have to continue the procedure of the remaining part. Okay, now here from the eigenvalues we get algebraic multiplicity as 2. Now I'll want to check the geometric multiplicity for the similar eigenvalue and distinct eigenvalue. For the distinct eigenvalue, anyway we get eigenvector, but once we have to observe the repeated eigenvalue that corresponding eigenvector. Okay, for that, first of all, I'll find out the lambda is equal to 5, that corresponding eigenvector. What about the concept that a minus lambda I into x is equal to 0? For finding lambda is equal to 5, that corresponding eigenvector. What about a minus lambda? Already we discussed in the first part of the answer, that is characteristic matrix form minus 2 minus lambda, minus 2 minus lambda, 2 minus 3, next to 2, 1 minus lambda, minus 6. Last one minus 1 minus 2 minus lambda. Into x as x1, here I am assuming as x, y, z is equal to 0, 0, 0. This is the characteristic matrix form with the unknown column vector x, y, z. Okay. For that here, what about lambda value? For which value we are finding the eigenvector? Lambda is equal to 5. Now substitute there, that is minus 2, minus 5, 2, minus 3, 2, next one, 1 minus 5, next one, minus 6, next minus 1, minus 2, minus 5, into x, y, z is equal to 0, 0, 0. That is minus 2, minus 2 minus 5 how much? Minus 7. And next 2. And the next one minus 3. Okay now. Next 2, 1 minus 5 minus 4. And the last element minus 6. And similarly minus 1 minus 2 and this is minus 5 into xyz is equal to 0, 0, 0. Okay. Now we are applying the echelon form. After getting that matrix form, now reduced as matrix as echelon form with respect to the row operations. Okay, if you are using the echelon form, easily we can get the unknown values of x, y, z. What about the concept of the echelon form? Echelon form means here whatever the diagonal elements -7, -4, -5. Below the diagonals are 2, -1, -2. We have to reduce the 2, -1, -2 are zeros with respect to the row operations. Okay, by using the echelon form. Okay, before applying the echelon form, first of all, I'll write it as, okay, I'll interchange the rows. That means R1 interchanges to R3. That is -1, -2, -5, 2, -4, -6, -7 to -3 into xyz is equal to 0, 0, 0. Okay, that is -1, -2, -5, 2, -4, -6, -7, 2, -3, xyz is equal to 0, 0, 0. From that now, I'll make it as 2 and -7 and 2 are zeros with respect to the row operation. For that, what about the row operation? R2 tends to R2 plus to R1. And the next one, R3 tends to R3 minus 7 R1. R3 minus 7 R1. For that, -1, -2, -5. Here 2 -2 with respect to R2. Okay, R2, I'll change with respect to R1, I'll make it as R2 first element as 0. That means 2 plus 2, 0. Next, -4, -4. This is -8. Next, -6, -10. -6, -10, -16. Similarly, what about R3? First one, anyway 0, R3 minus 7. Next, 2 minus 14. That means 2, 7 to the 14 plus 14, 16. 16. And next, -3, -3 plus 35. That is 32 into x1, x2, x3 is equal to 0, 0, 0. For that, is there any common term from after applying the row operations? Here I am applying R2 divides -8 and R3 divides 16. That is -1, -2, -5, 0, 1, 2, 0, 1, 2 into x1, x2, x3 is equal to 0, 0, 0. Okay, -1, -2. I'm taking with the R2 -8 common and R3 I'm taking 16 as common. That is -1, -2, -5, 0, 1, 2, 0, 1, 2. Here any possibility to make R3 as 0? That is R3 0 definitely with respect to R2. That means R3 tends to R3 minus R2. That is -1, -2, -5, 0, 1, 2, 0, 0, 0 into x1, x2, x3 is equal to 0, 0, 0. Now write it as equation form. Okay. From that, what about the first equation? -x1 -2x2. I mean, x1 means, okay, here I'm taking xyz, right? Either xyz or whatever it is, we are finding the unknown values. X, Y, Z. Now write it as equation form. From that, -x -2y -5z is equal to 0. Next, y plus 2z is equal to 0. Okay. Once observe here after reducing as matrix as echelon form, now I am writing that equations form. Solve the two equations. From that we get directly one matrix form. What about that matrix form here? How we are solving these two already we discussed in the last class. Okay, and in last problem. Okay, here let us assume z as k. If z as k means, what about y? Y is equal to minus 2k from the second equation. This is first equation and this is second equation. We are assuming z as k, one arbitrary constant. From that, what about y? Y is equal to minus 2k. From that, now we know that y and z. Substitute in the first equation. That is, what about the first equation? That is minus x, minus into minus plus 2 into 2, 4k, 2 and y value minus 2k, that is 4k, minus 5 into z is equal to 5 into k value, z value k. That means minus x minus 4k minus 5k minus k is equal. Minus x is equal to what? K. Therefore, x is equal to minus k and z is equal to k and y is equal to minus 2k. Okay, therefore, okay, now write it as vector form, column matrix form, that is x as k, y as minus 2k and z as k. Okay, I'll write it there. Therefore, x1 is equal to xyz, that is x as minus k, y as minus 2k and z as k. From that, I'm taking minus k outside, that is 1, 2, minus 1. Okay, this is one eigen vector for the corresponding eigenvalue of lambda is equal to 5. Okay, then, okay, now we get one eigenvector, that is 1, 2, minus 1. Similarly, we have to find distinct similar eigenvalue eigenvectors. Okay, here, whatever the similar eigenvalues, lambda is equal to minus 3. For that, we are discussing the concept. Next one, if lambda is equal to 3. For that case, what about the eigenvector form? A minus lambda into x. There we have to substitute in place of lambda as minus 3. That means this is minus 2. If lambda is equal to minus 3, for that case formula, a minus lambda I into x is equal to 0. But here a minus lambda I.
టైం ఎక్కువ లేదు మేడం, ఇలా 10 మినిట్స్ ఉంది అంతే, 10 మినిట్స్ కూడా లేదు, అయిపోతుంది. అయిపోలేదా?
అయిపోతుంది.
ఎంతసేపు పడుతుంది?
5 minutes అవ్వలేనా?
ఒక్క 5 మినిట్స్ అంటే అడ్జస్ట్ చేసుకో.
ఎందుకు సార్ స్టాప్ అయిపోద్దా?
కార్డ్ ఫిల్ అయిపోయింది సార్.
సరే, నేను చేసేస్తాను. ఓకే,
5 మినిట్స్
minus 2, minus 3, 2, minus 3, 2, 1 minus lambda minus 6, minus 1 minus 2, minus 3 into x. Here x, no? That is, here we have to substitute lambda is equal to minus 3. For that case, here we get 2 eigenvectors. Okay, with the same concept. According to that same, here a minus lambda I form is this. Okay, this is a minus lambda I form. There we have to substitute, there we have to substitute lambda is equal to minus 3 and after that reducing as matrix as echelon form. Okay, from that echelon form, after getting that echelon form, write it as equations. From that equations, here we get 2 eigenvectors. Okay, 2 eigenvectors. What about the 2 eigenvectors? Here the 2 eigenvectors are, first one, first eigenvector as 2 minus 1 0 and the second eigenvector as 3 0 1. Okay, so that here we get 2. For the similar eigenvalue lambda is equal to minus 3. For that case, we get 2 eigenvectors, that is 2 minus 1 as 0 and x3 as 3 0 minus 3 0 1. Therefore, what about the similar eigenvalue geometric multiplicity? Here we get 2 linearly independent eigenvectors, so that the geometric multiplicity is 2 and algebraic multiplicity is 2. Therefore, AM is equal to GM. Therefore, for the given matrix is diagonalizable. Okay, then we have to continue the further procedure of the diagonalization. Sometimes the two are not equal. For that case, we have to stop the procedure for the diagonalization of the matrix, then directly write down the given matrix is not diagonalizable. Okay, but here the two are equal, then these two, the given matrix is diagonalizable. That means what? After getting the eigenvectors, write it as one matrix form. That matrix as P, that is 1 2 minus 1, 2 minus 1 0, 3001, that is model matrix. That is model matrix of A. For that we have to find determinant of P value, that is equal to -8. Okay, after getting that determinant of P, now we have to find P inverse. Then what about the P inverse? Adjoint P by det P. Okay, already we discussed the last class, same concept here we have to apply. From that we get adjoint P value, P matrix -1, -2, 3, -2, 4, 6, -1, -2, -5, and that P value -8. Okay, from that we get P inverse. Okay, therefore what about P inverse? After getting that P inverse, multiply P inverse with A into P. Okay, multiply that 3. Okay, this is P inverse matrix, A as given matrix and P as model matrix. Multiply that 3, from that we get one matrix form. Once observe what about the matrix form? This is the diagonal form of the matrix. That is 5 0 0 0 minus 3 0 0 0 minus 3. Okay, here we have to apply directly from the scientific calculators also. We get the same answer, or else manually multiply. If we are multiplying any procedure, we get directly the same answer. Okay, there we get 5 0 0 0 minus 3 0 0 0 minus 3. Once observe, after getting the diagonal form, this diagonal matrix is called as what? A spectral matrix. Spectral matrix. Once observe, this diagonal matrix, diagonal elements are always equal to what? Eigenvalues. What are the eigenvalues? 5 minus 3 minus 3. There also, after getting the diagonal form, there also we get the same values, 5 minus 3 minus 3. So that the given matrix is diagonalizable and it is verified. Therefore, diagonal matrix is this. Okay, this is the concept for the diagonalization of a matrix. Here we discussed how many questions? We discussed two questions. Okay, in the two questions are different. One is okay, distinct eigenvalues with the calculation of a power 4, and another one also diagonalization of a matrix. Okay, next class we will discuss with other concepts of the matrix. Thank you for all. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.